Welcome to clickmyproject.com. Our project title is Hybrid Decision Tree and Naive-Based Classifier for Multi-Class Classification Task. Now we have to see the abstract of our project. In this concept, we have to mining the hybrid algorithm to increase the classification accuracy rate of decision tree and naive-based classifier for the classification of hybrid class heights. We have to identify the decision tree and naive-based classifier using the weather dataset or the Choya dataset. In this classification, we have to classify each the parent node and the child node, and then it is useful for proficiency and commonly used for solving the classification issues in data mining. In the second proposed hybrid NP classifier, we employ the DT instruction to select a reasonably more important subset of attributes for the production of native postulations of class conditional independence. In this clustering concept, we have to clustering the head and the parent node of each dataset in weather and SOAS. If the user select any one of the dataset, we have to identify classification and the acquired decision trees, and finally we have to implement the entropy of for each head and parent node and the child node for each classifications. Parent and child node, we have removed the noise in training dataset. In this remaining category, we have removed the acquired DT nodes, and we have to identify the decision tree for using this algorithm. And after identify the decision tree, we have to implement the naive-based classifier for the classification of multi-class hitches. We have to identify the probability value for each parent and child node, and we have to find the accuracy for each data set, and we have to selection of dealing with the missing characteristics values and reducing the noise in training data project. Is a load. First of all, we have to load the data set and update into the database, and finally we have to a parent node extraction. That means we have to analyze the parent, which is a parent and which is a child node from the data set, and after that we have to analyze. We have to store into each data into the database. And then we have to identify the DT classifier. In DT classifier, we have to identify entropy and the information gain. Entropy is nothing but we have to identify the support for each parent and child node for all the categories, and finally if the entropy is contains 0, we have it's like a noise category, and that we have removed that node and create a decision trees. And then you find the information gain. The information gain is used for which is come first and which is come and second. That lies which is the left node and which is the right node. And then we have to identify the naive-based classifier. The naive-based classifier is the second part. In that we have to identify the probability value for selected rules and overall rules, and we have to compare with the selection and non-selection categories and find out the accuracies and sensitivity for each data set or is a input, and finally we have to perform the evaluations, and finally we produce a graph for each algorithms and the existing and proposed systems. Now we have to run the home page. This is our home page for our project, and then now click the data mining picture. Now we have to select to browse any one of the file from the JFile chooser. The content dataset folder. Click dataset folder and then select any one of the text for the is a input. Now I select the choya.txt. Here the Choya file dataset should be loaded in the JText area, and then we have to load datas. We have to click the insert button. The Choya reports are inserted into database successfully, and then is a inserted data should be shown in on this tables. Next, click the decision tree. Is a counting number of parent nodes in our data set, and we have extra to now our parent node is red choya, butter choya and the white choya. Then we have perform classification for each soya type. and also stored in our database. So now we have to store the database for classification result. Is a node 1, is a node 2, and is a node 3, and identify the DD identify. Here we have to identify what are the rules that had been matched for the decision tree. So we have to select any one of the rule for the cancer or diabetes. This is a concept for which category is used for cancer and diabetes patient, and what type of soya type contain carbohydrate, fat, and proteins is must for cancer patient or diabetes patient. So we have select any one of these rules and click cancel. If this rules occurs in our data set, it will show our path. So we have to refresh to change to identify another categories. Then is the acquired DT. Then we have to find out the entropy for each data set. The entropy in red soya, white soya, and butter soya is a parent node, and find the cancer and diabetes. How many times in red soya the cancer occurs and diabetes occurs, and we have to identify for all red soya, white soya, and butter soya. And also we perform the information gain for each type. The entropy values, the parent and patient and parent node for entropy values, and if also we find out the entropy for all child node. The child node sugar and diabetes, and find out the entropy. And next child node is the saturated and unsaturated fat for child node. And then we have to measure the entropy for another child node is a tryptophan, trione, and serines, and find out the log2 values. And finally we had find out the entropy. Now it is the information gain values, and is a play, is a no play. Is a decision tree. The decision tree is acquired decision tree from finally we have to remove the noise from our data set, and we have to generate the decision tree for our data set. Is a graph for our process, is a weather and the soya beans. Next we have apply the naive-based classifiers. We have to select any one of the rule from the data set. Is a rule for the soya type is white soya, and carbohydrate dietary fiber, and fat is saturated, and protein is tryptophan. And we have to save your rules and go and click next button, and extract the rule result, and extract the occurrence as the probability value to find out the occurrence for each soya type, and this is the occurrence for the selected rule types. And also we have find out for each child node in our data set. In child node, where if the rule occurs, the rules are selected occurrence or display in this categories. Is another child node. And finally we have to calculate overall probability values, and click the classifier buttons. We have to measure the accuracy, sensitivity, and precision and specificity, and finally we produce the report. The soya graph is a weather graph, and then we have to perform genetic algorithm is a future enhancement. Thank you.